Hello everyone. Yeah. Uh, so let's us start today's online training. So at first, I would like to introduce today's members for training. So today, the same as the last training, the Ko Kikuchi will make a presentation. And then also today here, he is, some of you already met him, the Satoshi Matsumura. He is a sales engineer. He has many experience for making demonstration for welding application. So he come here to advise us some of your question and answer session.
From now, we will introduce an overview of welding. Welding is used for many situations, like automotive body and shipbuilding, and constructions and aircraft engine. Recently, there are several needs to improve stability for welding and reduce the weight of body. So we think the market need for improving welding efficiency is increasing around the Asia market. Usually, when we shoot welding with ordinary camera at 60 or 100 frames per sec and without filter, it is difficult to visualize a welding pool to be interrupted by strong light, like image on the left side. If we shoot welding pool with high-speed camera at over 1,000 and 10,000 frames per sec and using appropriate filter blocking the strong light, we will be able to visualize the welding pool clearly. By observing the welding pool, it can be helpful to investigate the cause of defect about welding. Usually, the point of visualizing welding is sputter, fume, and drop behavior, and arc behavior, and welding pool, so on. By capturing the phenomenon of these points during welding, it can be helpful to investigate the welding efficiency and cause of defect. In main type of welding, there are two types of arc welding and laser welding. Especially in arc welding, there are several types like Mag Welding and MIG welding and TIG welding, so on. This is overview for all types of welding. In arc welding, there are several types like plasma and resistance welding, in addition to Mag, MIG, TIG welding. In laser welding, there are main three types of laser, as fiber laser and disc laser and semiconductor laser welding. In addition, there is laser hybrid welding. This welding is the method combined arc and laser welding. Main base material are iron and steel and copper and aluminum. From now, we will introduce the required accessory for shooting welding. There are mainly three checking points for shooting welding with high-speed camera. First one, selecting color or monochrome camera. Second one, selecting appropriate filter according to the shooting condition. Third one, selecting appropriate light source according to the shooting point customer want to visualize. About these points, it depends on the base material and the point to visualize, the type of welding, and wavelength and the power of laser, so on. We will share with you the difference between the color and the monochrome camera for shooting welding. About color camera, we can capture the same image as we see with the human eyes. About mono camera, we can capture the welding pool clearly by extracting only certain wavelengths. This graph shows the general spectral characteristic and wavelength range for arc welding and laser welding. Left graph is about the arc welding. In arc welding, light of arc emits a wide range of light from the visible range to infrared range. Right graph is about laser welding. In laser welding, it emits strong light near the wavelength laser. In this graph, it emits the strong light near 1070 nanometer fiber laser. Strong light of arc and laser will prevent from visualizing the welding pool. So it is difficult to visualize the welding pool with camera in normal status. When we visualize the welding, if we use filter blocking strong light, we can visualize the phenomenon of welding pool clearly. Like this figure, we need appropriate filter blocking the strong visible light and infrared light in order to visualize the welding pool. Next, we will share with you the type of filter we usually use for shooting welding. There are mainly three types of filter we usually use for shooting welding. First one, a bandpass filter. Bandpass filter is a filter transmitting only specific wavelengths. Second one, the notch filter. Notch filter is filter blocking only specific wavelengths. Third one, ND filter. ND filter is filter lowering the overall brightness. About ND filter, we usually use it when we cannot adjust the brightness of image, only adjusting the shutter speed and aperture. Next, we will share with you the type of light source we usually use for shooting welding. About shooting welding, it is common to use the light source to illuminate the area around the welding pool. There are mainly three types of light source for shooting welding. First one, the halogen light source. The wavelength of this light source is from visible to infrared light. This light source has advantage of low cost, but there is a heat problem. In addition, the lifetime of lamp is short. Second one, the LED light source. There are two types of LED light source we usually use. White LED light source is for only visible light, and IR LED light source has several wavelengths like 740 and 815 and 940 nanometer. This light source has advantage that does not generate the heat like halogen light source, and the lifetime of LED is longer than halogen light source. So in Japanese market, it is most common to use the LED light source to shoot welding, considering the cost and heat problem. Third one, the laser light source. We usually use two types of laser light source. Laser light source has advantage of high power, but this light source is high price, and it is required permission from customer to use laser light source because such laser light source is class 4 laser. From now, we will introduce the point for shooting arc welding. About type of arc welding. There are several types like Mag, MIG, TIG, and plasma and resistance welding. The base materials for arc welding is usually iron and steel and copper and aluminum. About Mag welding. Mag means a metal active gas. Mag welding has advantage that it can weld at greater depths. In addition, the Mag welding is usually used for robotics welding. About MIG welding. MIG means the metal inert gas. MIG welding has advantage of being easy to weld in tight spot. About TIG welding. TIG means the tungsten inert gas. TIG welding has advantage of less sputter and suitable for precise welding. But this welding has disadvantage of slow welding speed and low power. About shooting arc welding. It is common to use a light source to illuminate the area around the welding pool. And it is common to select the bandpass filter, which transfer only same range of wavelengths with light source. Like this figure, by using bandpass filter, we can visualize welding pool clearly, while blocking the strong light around the welding pool and transfer only same ranges of wavelengths with light source. About selecting bandpass filter for shooting arc welding, we usually select it according to type of light source for shooting welding. First one, when we shoot arc welding without any light source, we usually select 916 nanometer bandpass filter, which transfer only infrared light. Second one, with IR LED light source. We usually select bandpass filter of same wavelengths as IR light source. For example, we use 852 nanometer IR LED light source. We should select 850 nanometer bandpass filter. Third one with laser light source. We usually select bandpass filter of same wavelengths as laser light source. For example, if we use 810 nanometer laser light source, we should select near 810 nanometer bandpass filter as well. From now, we will share with you the detailed information for shooting Mag welding and MIG welding. In Mag and MIG welding, iron and steel and aluminum is usually used as base material. Required frame rate is from 2000 to 10,000 frames per sec, and required exposure time is from 10 microsec to 5 microsec. About video on the left side, it shows the image of the welding pool when we shoot without light source. We use 960 nanometer bandpass filter because we don't use the light source. About video on the center, it shows the image of welding pool when we shoot with IR LED light source. We use 850 nanometer bandpass filter because the wavelength of IR LED light source is 850 nanometer. About video on the right side, it shows the image of welding pool when we shoot with semiconductor laser light source. We use 940 nanometer bandpass filter because the wavelength of semiconductor laser is 940 nanometer. About TIG welding, iron and steel, aluminum, and copper is usually used as base material. Required frame rate is from 1000 to 5000 frames per sec, and required shutter speed is from 10 microsec to 5 microsec. About video on the left side, it shows the image of welding pool when we shoot with halogen light source. We use 960 nanometer bandpass filter because of the halogen light source. About video on the right side, it shows the image of welding pool when we shoot with IR LED light source. We use 850 nanometer bandpass filter because the wavelength of IR LED light source is 850 nanometer. About resistance welding, iron and steel and copper is usually used as base material. Required frame rate is from 10,000 to 20,000 frames per sec. And required exposure time is from 100 microsec to 20 microsec. The method of resistance welding is usually used for welding of car body. We need to ask customers to arrange the experimental environment in order to set the camera at the appropriate point, because the welding is usually performed in the center of base material. In this video, a customer welds the edge of the base material for experimental purpose. About video on the left side, we shoot with color camera because our customer wants to observe the heat transfer on the base material. About video on the right side, it shows the image when we shoot resistance welding with semiconductor laser light source. We use 810 nanometer or 940 nanometer bandpass filter according to the wavelength of semiconductor laser light source. From now, we will introduce a point for laser welding. About type of laser welding, there are several types like fiber laser, disc laser, and semiconductor laser. In addition, there are laser hybrid welding, which is combined with laser and arc welding. The base material for laser welding is usually iron and steel and copper and aluminum. Laser welding has advantage that it can weld deeper. Laser welding is low heat influence and low deformation from welding. On the other hand, safety management is required for laser light, and laser welding equipment is high cost. About this image, we shoot laser welding at 100,000 frames per sec with ACS1. In laser welding, we sometimes are required to shoot at high frame rate, like this image. This is the main type of wavelengths of laser welding. About YAG laser, wavelengths about YAG laser is 1064 nanometer. This laser is usually used for processing of electronic parts. About semiconductor laser, wavelengths about semiconductor laser is 818 and 940 and 980 nanometer. This laser is usually used for 3D printer. About disc laser, wavelengths about disc laser is 1030 nanometer. This laser is high quality and high power. About fiber laser, wavelengths about fiber laser is 1070 nanometer. This laser is high power and low cost. This laser is most common in type of laser welding, considering the cost and power. In addition, in Japan, some research about blue laser and green laser is beginning recently as a different approach for laser welding. I will introduce a way to select appropriate filter for laser welding from now. When we visualize laser welding, we need to prepare two types of filter. First one, notch filter. Notch filter is blocking near laser wavelengths. Second one, the bandpass filter. Bandpass filter is transmitting only same ranges wavelengths with light source. Like this figure, by notch filter, we can block strong light of laser. And by bandpass filter, we can transfer only near same ranges wavelengths with light source and block strong light around the welding pool. We can visualize welding pool clearly using these two types of filter. Like this figure, when we shoot YAG laser welding, wavelengths about YAG laser is 1064 nanometer. So we need to select 1064 nanometer notch filter to block strong light of YAG laser. In addition, we need to select appropriate bandpass filter according to type of light source. If we select 850 nanometer IR LED light source, we need to select 850 nanometer bandpass filter transmitting only wavelengths of IR LED light source. When we shoot fiber laser welding, wavelength about fiber laser is 1070 nanometer. So we need to select 1064 or 1070 nanometer notch filter to block strong light of fiber laser. In addition, we need to select appropriate bandpass filter according to the type of light source. If we select 810 nanometer laser light source, we need to select around 810 nanometer bandpass filter, transmitting all the wavelengths of laser light source. Like this figure, when we shoot laser welding, we need to select appropriate filter according to type of laser and light source. I will share with you the example about general shooting condition for laser welding. In this case, the type of laser is fiber laser. The power is 4 kilowatt. The wavelength of laser is 1070 nanometer. The base material is steel plate for automotive. When we shoot at 5000 frames per sec and exposure time is 20 microsec, we used 852 nanometer IR LED light source. Then we used 1064 nanometer notch filter to block strong light of 1070 nanometer wavelength fiber laser. And we used 852 nanometer bandpass filter to transmit 852 nanometer IR LED light source. Like this example, we need to select appropriate filter considering the type of laser welding and light source. Here is an important point to be careful about base material. If the base material is aluminum and copper, the melting point is low, so the welding pool shows little dark. We heard from many customers that they can get better image when they use color camera to observe the behavior of welding pool on aluminum and copper. Like this image on left side. If we shoot welding pool of copper with mono camera, the welding pool shows little dark. In the image of right side, we shot the welding pool of aluminum with color camera. Many people might think that image is more clearly, and they can observe the behavior of welding pool more clearly. From now, we will introduce the demo sequence from setting to shooting with video. Finally, we would like to review the latest Arc camera model like Q2M and ACS series, because this model is very appropriate model for welding application. Q2M can shoot at full resolution of Full HD at 2000 frames per second. The size of this camera is same as palm of hand. The weight is 670 grams. And you can put Q2M with laser head. You can shoot the behavior of welding with movement of laser head. ACS1 has high resolution and sensitivity. When you shoot laser welding required high frame rate, you can shoot with high resolution and more clearly. ACS3 is compact model of ACS1. It is smaller and lighter than ACS1. And this camera is appropriate model for laser welding like ACS1 too. We add the image quality mode and HDR mode to ACS3 recently. In image quality mode, we can improve the image quality of ACS3. About HDR mode, HDR can improve the dynamic range wider, so we can shoot several areas from lower brightness to higher brightness together. We will introduce a detailed information about this mode another time. Finally, we summarize the checking point for shooting welding. When you have a meeting with your customer, you should check this checking point before making demonstration. And base material, type of welding, and shooting situation, and wavelength and power of laser welding, and point to visualize. Customer want to visualize. And in addition, we need to select appropriate accessory for shooting welding. We should select mono camera or color camera to shoot welding, and what kind of light source and filter we should use. Before shooting welding, it is important to check such checking point. Thank you for your time.
Okay, thank you very much for today's participating to today's event. We would like to see you at the next event. Okay, thank you.
Thank you.
Bye.